This is number 4 from the 2003 AP Calculus AB exam. Okay, we are given the graph of f prime here, and f is a function defined on a closed interval from -3 to 4. It's -3 to 4, with f of 0 equal to 3, and the derivative consists of one line segment and a semicircle. Okay, so part A. On what intervals, if any, is f increasing? Well, we know that a function is increasing if its derivative is positive. So where is that happening? F prime is positive from -3 to 2. That's the only place that our function's above the x-axis. So we can say that f is increasing on -3 to 2, -2, because f prime is positive on that same interval. Okay. Next, part B, we need to find the x-coordinate of each point of inflection. Okay, so where do points of inflection happen? Well, that happens where your second derivative changes sign. So that means that our first derivative would go from increasing to decreasing or decreasing to increasing. So where does that happen? Our first derivative changes from decreasing to increasing at x equals 0, and then from increasing to decreasing at x equals 2. So that is our answer. That's happening at x equals 0 and x equals 2 because f prime changes from decreasing to increasing at x equals 0 and from increasing to decreasing at x equals 2. Part C. Find an equation for the line tangent to the graph of f at the point 0, 3. Okay, so we've got our y1 and we've got our x1, and now we need the slope. We need to know what f prime of 0 is equal to. And we can get that from our graph. Here's f prime of 0 is -2. So this is -2, which means our slope is -2, and that is our line. If you prefer, you can write this as y equals -2x plus 3, but I don't know why you would do the additional work when you can just leave it like that. Okay, part D. Part D is actually pretty cool. Now remember, we were given this piece of information up here that f of 0 is equal to 3. So we have one function value, and we're looking for another function value. So this tells me that I might want to get into the Fundamental Theorem, which tells us that this is true. So what do we have? For f of -3, we can set up the integral from -3 to 0. I'm using 0 because that's what we have. You could also go from 0 to -3. I just like to go in order. Of f, whoops, change back to my pen here, of f prime of x should be equal to f of 0 minus f of -3. So what values we have? We know f of 0 is equal to 3. We're looking for f of -3, and we can certainly calculate this integral based on our graph. So -3 to 0. Well, what I see is this triangle here has equal area to this triangle here. So these will kind of cancel out because one's above and one's below the x-axis. So what we need is to find the area of that trapezoid and then negate it because it's underneath the x-axis. So what do we have? A base of 1, a base of 2, and a height of 1. So let's put that in. We've got a base of 1, a base of 2, and a height of 1. So we do need to negate this because that's underneath the x-axis. So it's negative 3 halves equals 3 minus f of negative 3, or f of negative 3 is equal to 3 plus 3 halves, and that is 9 halves. So f of negative 3 is equal to 9 halves. So let's do the same thing with our f of 4. So we want the integral from 0 to 4, because we're looking for f of 4, but we have f of 0. So looking for f of 4, f of 0 is 3. So the integral from 0 to 4. Now you know what this is? This is a shaded area problem that you used to do maybe in middle school, where we just want to know the area of these two regions right in here. And the way we find that is we find the area of the rectangle and then subtract out the area of the semicircle. So the area of the rectangle would be 4 times 2, but then we have to subtract the area of the semicircle. So that would be 1/2 the area of a circle, or 1/2 pi r squared, and the radius is 2. So what do we get? 8 minus, that's 4, half of 4 is 2. Now these regions are underneath the x-axis, so we have to negate this. This is going to be negative 8 plus 2 pi. So let's put that in. Negative 8 plus 2 pi. So that means that f of 4 is equal to 2 pi, we're going to add 3 to both sides, minus 5.